So moving on to questions 7 and 8, I've already circled the answers, but let's just go over these. Which of the following conditional statements is correct for the given information? The hypothesis is this phrase, 6x minus 5 equals 25. The conclusion is 6x equals 30. And the way we form our conditional statement is if hypothesis, then conclusion. So in this case, we would say if 6x minus 5 equals 25, then 6x equals 30, and that is answer C. On number 8, we're asked which of the following statements is the correct converse for the given information. So here the hypothesis is the phrase, a number is divisible by 6. The conclusion is it divisible by 2? It is divisible by 2. So the statement would be, if we were asked just to give the conditional statement, it would be if the hypothesis, if a number is divisible by 6, then the conclusion, then it is divisible by 2. But since we were asked for the converse, we've got to ask if it is divisible by 2, then the number is divisible by 6. So that would be answer C. If a number is divisible by 2, then it is divisible by 6. Notice that we just switch the hypothesis and the conclusion. Let's look at number 9. This is the statement we have to deal with. The measure of an acute angle is between 0 and 90 degrees. And then which of the following statements is the converse of this statement? So this is not in an if-then form. We have to get it into an if-then form. So what would it be? The topic of the sentence is acute angle. So if an angle is acute, then the measure of the angle is between 0 degrees and 90 degrees. So let's see which of these statements comes the closest. If an angle is an acute angle, then its measure is between 0 and 90. I think that's it. Okay, so that is the, that is the statement, but it's not the converse. Okay, so I can make mistakes too. That was the statement, but we have to choose the converse. So A would be the conditional statement itself, but what's its converse? If the measure of the angle is between 0 and 90, then the angle is acute. And that would be C. Okay, this is the converse. If an angle has a measure between 0 and 90 degrees, then it is an acute angle. Okay, good. Let's go on to number 10. It says for 10 and 11, write the conditional and the converse of the given biconditional. So this is something we haven't done before. We're given the biconditional, and we have to rediscover the conditional and the converse. So two angles are congruent if and only if, this is our if and only if phrase, they have the same measure. So remember that originally that would have read, if this piece, if two angles are congruent, we're adding the if, then we put this piece, then they have the same measure. Okay, good. And the converse would be, if two angles have the same measure, then they are congruent. Okay, good. Statement number 11. A swimmer wins a race if and only if she swims the fastest. So this originally was the hypothesis, and this was the conclusion. So let's put in the if before this and the then before this to give us if a swimmer wins a race, then she swims the fastest. And the converse would be, if she swims the fastest, then a swimmer wins a race. If a swimmer swims the fastest, then she wins the race. Or then the swimmer wins the race. You could say it either way. She or the swimmer. Okay, so let's move on to the last three questions, 12, 13, and 14. We have to determine if inductive or deductive reasoning is used to write the statement and then supply the reason. Well, they all have reasons, so we could be pretty sure they're all deductive reasoning. Okay, so reasons are provided, logical reasons are provided only when we are dealing with deductive reasoning. So let's take advantage of the sketch. We're supposed to sketch a figure, and let's try to come up with the statement and the reason. We are given that line segment BD bisects angle ABC. So let's write angle ABC, and we have line segment BD bisecting it. That means that the two resulting smaller angles are equal to each other, right? So the measure of angle ABD equals the measure of angle DBC. That's by the definition of angle bisector. Okay, good. Let's go to 13. Point W is between R and T. So let's sketch this out. We have R and T, and we have W between them. Well, I've sort of made it look like W is sort of midway between them, but we don't know that. All we know is that W is between them. It could have been over here. It could have been over here. Well, the definition of being between geometrically, it has a very specific definition. It means that the distance between R to W plus the distance between W to T is exactly the same as the distance between R to T. Remember, the shortest distance between 2 points is a straight line. So that means that point W has to lie on the line segment RT, and then we could use the definition of in between, or we could use the segment addition postulate. You can kind of use either one. So the statement would be the measure of RW plus the measure of WT is equal to the measure of RT. And it would be a definition of between geometrically and or the segment addition postulate. Okay, and then finally we come to question 14, and we are given that G is the midpoint of DB. So G is the midpoint of line segment DB. Let's draw that out. DB. And in this case, G is just right in the middle. And the statement would be that the measure of DG equals the measure of GB. And that's by the definition of midpoint. Okay, and that concludes the independent practice.